Advent of Code 2016 Day 4. You may notice I've also made some improvements to my Advent of Code proxy so that it more often works on the first try. Right, what's the problem? You come across an information kiosk with a list of rooms, blah blah blah. Remove decoy data. Each room is an encrypted name. Letters separated by dashes, followed by a dash, followed by our ID, followed by a checksum. A room is real if the checksum is the 5 most common letters in order, with times broken by alphabetization. Some of the sector IDs from the real rooms. Okay, let's get some input. I think we'll do the thing of reading a character at a time. So in fact, we can ignore the dashes completely. We just read letters, and then we read numbers, and then we read a square bracket, and then the letters in order of frequency, and then another square bracket. The fact that the dashes are irrelevant probably suggests that the dashes are relevant for part 2. And so far it looks like every input is of the correct form, so we don't even need to do very much validation. We just need to check that the letter frequencies are correct. Although there might be the odd one in there, just to throw me off. I can see in the logging output of my Advent of Code proxy that the size of this input is about 40K, and the program on SCAMP buffers it in memory. The kernel takes up about 16K, so that leaves 48K of memory for the program. So as long as if the program is bigger than 8K, then it's actually going to overflow and overwrite some of the kernel with this input. So I might just check how big the AOC program is. Ooh, it's 9K. So SCAMP may be about to crash unless the first 1K of the kernel doesn't get used, but I expect it does. Yes, it looks like there's some important stuff in the first 1K of the kernel. So this is almost certain to crash just as it gets to the end of the input. Is that it? Has it crashed, or is it working? Oh, it looks like it's worked. I wonder how that worked then. The input was 40K. The kernel is 16K. And the program is 9K. 40 plus 16 plus 9 is more than 64. Well, I don't know, it looks like we got away with it there. We want the sum of the IDs of the valid rooms. So this is a loop for each line. How many lines is this file? The IDs were mostly 3 digits, weren't they? So if we assume the average is 500, 500 multiplied by the number of lines will give us the expected magnitude of the answer. And if that will overflow 16 bits, then we need to take care of that. In fact, I know already that it will. Because if it's 200 lines, then the expected magnitude is 100,000. Yeah, okay. So we expect it to be about 500,000. So we need a big int to store the count. And we want 2 words per value. So right, for each line, read letters, read sector ID, read open curly brace, read 5. Is it always 5? I think it was from what I saw. Letters. Check that they're in order. Read the closing brace and read a new line character. And at the end, we'll print the big num. So having read the letters, we only need to know the count of each letter. So we can then sort the counts. So actually we want a so we'll call this one total. Okay, and then we want another one which maps a letter to a count for that letter, and on the loop we'll start by setting them all to 0. Now we need a character that we're reading in. If it's dash, we ignore it. If it's a digit, then we break, and we need to remember that the sector ID, the first digit of the sector ID has already been read. So we'll say that to start with. Otherwise, oops. That pattern seems to be quite common. I wonder if I should have a neater way to do that. And then after the digit we don't have a thingy, then we've gone wrong. Okay, back to this. So if it's not a dash and it's not a digit, then it must be a letter, in which case count of character minus a plus plus. Don't know if slang actually has syntax for post increment of an array subscript, but I guess we'll find out. So that reads the letters and counts them. Now we need to sort them. So we want to sort count 26 elements with a comparator function which goes return count. So we want the highest first. So if count B minus count A, this should return a number less than 0 if A should come before B, which means A is bigger than B, it should be less than 0, which is what we've got. Good. Read the sector ID, we've done. Read the thingy, we've done. Read 5 letters. So do we need to validate it? I think we do. And then we require that this isn't going to work because we've lost track of which letter corresponds to which element. So instead, each element of count needs to be a pair. Of a character, and then actually it can just be malloc2, can't it? And then in reset count we'll go, that needs an I++, I equals 0, I is less than 26, count I 0 equals A plus I, and count I 1 equals 0. And then when we add 1 to the count, we need to increment that part, and this needs to check, whoops, that part. Okay. And now if we need to that's interesting. It's all gone a bit corrupted on my screen, but it looks fine on yours. Mine seems to be working. I've done that thing again where I forgot to focus the window. I'll put that on my checklist. Right. We need to check that the characters we read match what's in our now sorted count array. So if count I0 is not equal to ch, then valid equals 0. But we can't break because we still need to read all the characters in. Okay. And then if valid, then big add word total sector ID. then okay, that should be that. I think that's a complete solution, so let's try and run it. Recognize, oh yes, I forgot. Unary operator plus needs operand. Okay, is that the array subscript thing I was talking about? Oops. Yes, it is. So I think we can do this. What the hell? Unary operator plus needs operand. Unary operator plus. Not sure what's going on there. Right. So that's definitely line 36, but it doesn't like plus plus. Unary operator plus needs operand. Well, okay, fine. Just do E equals cat ch minus a, which is a pointer to a malloc 2, and the second element is what we want. Then we want the value of well, I can't complain about that, can it? Slang is mostly a lot like C, but there are quite a few little nice things that C has that I haven't bothered to implement in slang, and trying to increment the value at a pointer is evidently one of them. To be honest, at first it didn't even have array subscript syntax, but I got so tired of writing pointer arithmetic arrays that I just added it. And actually, looking at this line, value of p equals value of p plus 1, I'm slightly concerned that that might get passed as value of p equals value of p plus 1, which is not what we want. So if it gives, so in fact, if it gives weird answers, then I will put brackets around that, but we'll just try it for now. Actually, let's give it a sample input just to see, because the real input's quite long. So, for a sample input, that doesn't look good. Did I forget to put I++ in reset count? Ah, yes. The reason I can't control C it is because it's in an infinite loop, so it never touches the kernel. And the serial port, the console runs on a serial port. The serial port, in principle, would generate an input every time you type a key, but my CPU doesn't support interrupts. So the only way the CPU finds out you've typed Control C is if the program makes a system call of any kind. But since it's not making any system calls, there's nothing we can do other than reset it. Day 4. At least it doesn't take very long to boot. So I'm guessing Yes, I forgot to put I++ here. But while we're here, we'll also put brackets around this, just in case. No, that's precisely what I didn't want. That's what I wanted. Increment the value of pay, yes. Interesting. Still an infinite loop. Ah, but it's hitting the kernel now. Okay, maybe it's not an infinite loop then. Or maybe it's stuck trying to get char. Lol. What the hell? Oh. Yeah. I typed Control D to try and get back to the editor, but terminated my shell and got put back in the home directory. So, where do we think we're getting stuck? Oh. This loop has no termination condition. Right, okay. If we read an end of file here, then we need to set this and break. In fact, there's an easier way to do that. We'll just go. No, that'll be fine. Interesting. That is not the correct answer. It's because we forgot that we need to sort by the character as a tie break, I expect. Well, let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. 1, 2, 1. 1, 2, 3. A, B, C, D, E. No, it still says 0 for that one. Okay, well, we do need to do the tie break thing. But we also need to work out why it's not valid. So we should print the sort order after each line. Well, do we need the whole thing? Let's have the whole thing. Count I0 is the character, count I1 is the count, and then I++. Well, that's not sorted, is it? That seems to be in a random order. It's not even the order it was in to start with. Oh. Okay. That should just be that, I think. Because count has 26 pointers to malloc2s in it. So our function will get pointers to malloc2s. Right, but we also need to do the tie break. So if a1 equals b1, otherwise, if a1 equals b1, then if a0 is less than b0, well, we can just return. Then we want a0 minus b0, I think, because in this case we want the smallest first. If, let's say if a is a and b is b, yeah, that works. Just wondering if it's worth getting rid of all the print stuff so that we don't have to compile it again. I think that's going to be correct now. So I'm going to comment this out just to save spamming the terminal when we run it on the 40k real input. Yes, result. Now I expect we play the waiting game. Yeah, might not be too slow. Probably going to be faster than reading the input was. I should have added a progress indicator. I must remember to do that on the problems that have large inputs. I was about to say a progress indicator would be handy so that I would find out if there's a weird edge case where it runs into an infinite loop. But actually I have a better solution. If you look at the lights, then as long as these ones are flashing, we know we're going into kernel code occasionally. If it got stuck in an infinite loop, then we would expect the program counter to be staying in the user space part. So that's quite handy. You don't get that on a normal computer. Although if the infinite loop was read a character from the input and then do nothing with it and read another one, then it would get stuck at end of file and it would still appear to be hitting the kernel. So it's not foolproof. Although then we'd be able to type Control-C. Although how will we know? The lights seem to be pulsing like this. So I'm guessing the pause is where it's doing the sort, because the rest of it looks like it should be quite fast. So it's basically get char, get char, get char, which looks as if the lights are on, and then sort, the lights go off. Get char, get char, get char, get char, get char, get char, and then sort again. So if it's going maybe 2 a second, and there are 1,000 lines, then we can expect this to take about 500 seconds, nearly 10 minutes. Might just do something else for 10 minutes. Oh, there's an answer. Right, let's see then. Yes. The room names are encrypted by a shift cipher, nearly unbreakable. To decrypt a name, rotate each letter forward through the alphabet, a number of times equal to the room's sector ID. A becomes B, B becomes C, Z becomes A, and so on. For example, the real name for QZMT is very encrypted name. Okay, what is the sector ID of the room where North Pole objects are stored? Interesting. How would we know? Well, I think we need to decrypt them all and then look through the list manually. We might be able to do it by just guessing the word lengths. If it's likely to say North Pole objects stored here, let's just have a quick look at the input. If there's a 54764 length, oh, this won't fit in memory, will it? I can't look at this in this. So what did we say? North Pole object stored here. 54764. If there's one that's got 5 followed by 4, that's like to say North Pole. If my grep program supported regexes, this would be a lot easier, wouldn't it? I feel this is not going to be an effective way to solve the problem. So we'll probably have to decrypt them all. That's very annoying. Okay, we'll decrypt them all. So we now can ignore the checksum. We can no longer ignore the dashes. We need to we don't need the big num stuff anymore. We don't need the count. Otherwise, value of p equals character p plus plus. So we actually want dashes this time, so that we have a chance of reading the names. So we've read the word into memory. We don't need to sort the counts anymore. We don't want to read the sector ID. We want to read and ignore the letters. We don't actually need this validation either, because we already know it's correct. Oh no, haha. It's not correct if you delete the get chars, is it, Jess? Read 5 letters which we ignore. In fact, what I'll do after we've read the digit, I don't think we need any of this more. We'll go while get char is not equal to blank, do nothing. Okay, we've got the string, we've got the sector ID. So actually, p equals str value of p. So we'll iterate along every character in the string, shift it by ch minus a plus id modulo 26 plus a, and then output that, and then output a new line character, and hopefully that decrypts everything. So qzmt xmtky ivhz343 is very encrypted name. Very F encrypted F name F. Okay. Well, let's not try to decrypt the oops. Let's not try to decrypt the dashes, but the rest of it works. Are we getting the editor back? What's going on? Why has it crashed? I typed a Control Z, and I think the other day I typed a Control Z and it crashed. So I'll write that down. Why does Control Z make it crash? So is this actually unrecoverable now? It looks like it's in an infinite loop in the kernel, based on the lights. Ah, yes. Control Z is supposed to make it interrupt the program that's running and spawn a shell. So that part's obviously broken. Anyway, reset again. Right, what did I want? We wanted to make part 2 not try to decrypt dashes. Like that. And in fact, since we might solve it as it's going, I'll also make it print it to standard error. And then when we run it on the real input, we'll get to see it at the same time as it's going to a file. On a real computer, you get to pipe into T for things like that, but T doesn't work on SCAMP because only one process runs at a time. Ugh. I forgot to put the spaces on standard error. Yep, didn't put a new line character at the end on standard error. Oh wait, what did it want us to know? What was the solution? It wanted to know what is the sector ID of the room where North Pole objects are stored, so it might help if I printed the sector ID, mightn't it? Right, there we go. I wonder what I've forgotten this time. Well, I haven't seen anything that looks like North Pole object storage yet. I wonder if it's kind of a cryptic puzzle. I did notice the word storage a couple of times, I think. So maybe we just grep for storage and see which one looks like it's North Pole objects. Oh, hello! It just does say North Pole object storage. I was expecting North Pole to be 2 words. 501. Great. Well, that took a long time, mainly because of the size of the input. I think we ran up against a few more of SCAMP's limitations in this one, namely reading the input file, buffering the input file into memory, almost overwrote some of the kernel. In fact, I think it must have overwritten a little bit, but maybe it was just initialization stuff that doesn't actually matter at runtime. Maybe we could deliberately measure the size of the initialization stuff and throw it away after the kernel's initialized. So that would give more memory to the user programs. So kilo said out of memory after it tried to read the input file, because kilo actually checks the amount of memory. The AOC program just allocates a 16K buffer and merrily overflows it if there's more than 16K of data. What other limitations do we have? We can't pipe into T because it only runs one program at a time. I feel like there was another one, but I can't remember now. Anyway, that was a fun puzzle. Thanks for watching.